finding empirical formula. How to find the empirical formula? Let's say you have done the experiment. Empirical formula is the formula that we get from experiment. Okay, let's say you have done the experiments. Usually they don't ask you to do the experiment, but they will straight away give you some data that obtained from experiment. So there are a few steps to find empirical formula. The first thing is you need to find the mass. Okay, the mass of what? The mass of each element. Okay, maybe you can write here the mass of each element. Okay, that's the first step. You list down all the elements and then you find the mass of each element. Now from the mass, then we can find the mole or the number of mole. Number of mole. Okay, number of mole of each element. Find the number of mole of each element. If you still remember, the number of mole is equal to mass over molar mass. Okay, mass over molar mass. We use this formula to find the number of mole. Okay, so we can find the number of mole by using mass over molar mass. After you get the number of mole, okay, then you can find the simplest ratios of each element. The whole number simplest ratio, because we already know the number of mole. Okay, then we can find the simplest ratios of the each element. So these are the steps to find the empirical formula. I will show you a few examples after this. Example 2. In the chemical reactions, 4.23 gram of iron reacts completely with 1.8 grams of oxygen gas, producing iron oxide. Calculate the empirical formulas of the iron oxide. Okay, now you see the first thing is we need to find the number of, the mass, right? Yeah, iron. First we list down the elements. We have iron and oxygens, right? And then so we need to find the mass. Okay, from here, we can see that the mass of iron is 4.23. 4.23. And the mass of oxygens is 1.80. 1.80 gram. You see, showing here. Okay. After we found the mass of each element, the second thing is we find the number of mole. Okay. In this case, the number of mole is already given. How to find this number of mole? Okay. Number of mole is equal to number of mole, N equals to what? Equal to the mass. So the mass is 4.23, so equals to 4.23 divided by the molar mass. The molar mass is always equal to the relative atomic mass. Always remember this. The molar mass is the mass of 1 mole and is always equal to the relative atomic mass for atoms, and is equal to relative molecular mass for molecule. So divided by 56, 56, and then we get this 0.0755. So this is number of mole. It's number of mole. For this one also the same. We take 1.8 and then divided by 16. Okay, then we get 0.1125. After we get a number of mole, then we need to find the simplest ratio. How to find the simplest ratio? Okay, so we find the simplest ratio by dividing these two numbers by a factor. But usually we take the smallest number as the factors. Okay, for example, 0.0755. Okay, we divide it by 0.0755 because out of these two numbers, these numbers is smaller compared to this. Okay, this 0.1125 is bigger than this 0.0755. So we divide this by 0.0755. Then we get 1. We get 1. Okay, and then this number 0.1125 also, 0.1125 again. Also we divide it by this 0.755. 0.0755. Then we get 1.5. So then we get this simple ratio. By the definitions, okay, the ratio must be whole number ratio. This is not a whole number. Okay, whole number we shouldn't have a decimal place like 1.5 or 1.2. Okay, so we shouldn't have that. So this 1 to 1.5 is not a whole number ratio. Okay, so to get a whole number ratio, what we do is we multiply by 2. 1.5 multiply by 2. This one we multiply by 2. Then we get this. Then we get 2, 3. That is the ratio, simplest ratio in whole number or round number, 2 to 3. That is what we want to get. Okay, this ratio is what we want to get, because after we get the ratio, okay, after we get the ratio, the formula is Fe2O3. Determine the empirical formula of a compound which has a percentage of compositions: magnesium 20.2%, sulfur 26.6%, oxygen 53.2%. So you see this one, we have three elements, right? Magnesium, sulfur, and oxygens. And we have the percentage of compositions. Okay, percentage of compositions. So let's list down the percentage of compositions: 20.2, 26.6, and 53.2. 53.2. Okay, so this is a percentage. This is a percentage in percent. Okay, but if you still remember, the first step, in finding empirical formula is to find the mass of each element. This is not the mass, just the percentage of compositions. So you must find the mass. How to find the mass? We already know the percentage. Okay, so you can assume any mass for the sample. But usually I would suggest my students to assume that the mass is 100 gram because that's easier for the calculations. Okay, if the mass is 100 gram and is 20.2%, then the mass will be 20.2 gram. 20.2 gram. But if you don't like 100 gram, let's say you say I like 150 gram. Can I use 150 gram? Yes, you can use 150 gram. Okay, but then that's harder for the calculations. Okay, but if you take the mass as 100 gram, then it's easier for the calculations. Straight away, 20.2%, 20.2 gram. 26.6%, 26.6 gram. Okay? This one is 53.2 gram. So if you know the percentage, you can find the mass easily by assuming any mass of the sample. Yep, any mass also can. Okay, let's say you say I want 1,000 gram, can or not? Sure, no problems. Okay, 1,000 gram, then this will be 202 gram. Mass equal to percent? No. Not really. Mass is not equal to percent. But if you know the percentage, then you can find the mass easily. For examples, I have a piece of this magnesium sulfate, okay? I know that 20.2% is magnesium, and then 26.6% is sulfur, and 53.2% is oxygens. Okay, what's the mass of this magnesium? Yeah, magnesium, sulfur, and oxygens. Depends on the mass of the sample, right? This is magnesium, this is sulfur, and this is oxygens. Okay, so what's the mass of magnesium, sulfur, oxygen? Depends on the mass of this sample. Okay, and we don't know the mass of this sample. We don't know the mass of this sample, but actually you can assume any mass of the sample. You can assume that it's 1,000 gram or 2,000 gram or 5,000 gram. Now let's say I assume that this is 50 gram. Okay, so I assume that this is 50 gram. If this is 50 gram, then what's the mass of magnesium? So the mass of magnesium will be 20.2 divided by 100 and then times 50. Then you will get the mass of magnesium. Okay, then you will find that actually it's not 20.2, it's 10.1. It's 10.1. Okay, so if you assume that this is 50 gram, then this should be 10.1. Okay. This will be 13.3, something like that. So not necessary the percentage and the mass must be the same. It depends on what's your mass for the sample. But if you assume that it's 100 gram, then it's easier for the calculations, right? Straight away, okay? 20.2%, 20.2 gram. Okay, so mass in 100 gram is easier, just easier or convenient for the calculations. Okay, now after we have this mass, then we can find the number of mole, right? The number of mole is equal to the mass, 20.2, divided by the molar mass. The molar mass is always equal to the relative atomic mass. Okay, for magnesium it's 24. 24. What's the number of mole of magnesium? 0.8417. 17. Okay, so that is the number of mole of magnesium. Okay, find the number of mole of sulfur and oxygens as well. Okay, so this is the number of mole. So the simplest ratios is 1, 3.99, right? Okay, we find a simple ratio by dividing the number of mole, okay, by the smallest numbers among these three. So for example, this one 0.8417, 0.8417, we divide it by 0.8313, yeah, 0.8313. Okay, most probably you get 1, okay, very close to 1. Okay, this one is 0.8313 divided by 0.8313. Okay, of course you will get 1. Okay, and the last one is 3.325 divided by 0.8313. Okay, you will get 3.99. Okay, or approximate to 4. Okay, if you get 3.99, then you can round it up to 4. So the simplest ratio is 1 to 1 to 4. Okay, so therefore, what's the empirical formula of this compound? What's the empirical formulas of this compound? MgSO4. Okay, that's correct. So MgSO4. So 1 magnesium, 1 sulfur, 4 oxygens. So this is the empirical formula for this compound. Okay, so that is how we find the empirical formula. Example 4. From an experiment, a scientist found that a hydrocarbon contains 85.7% of carbon according to its mass. Find the empirical formulas of the hydrocarbons. Okay, of course, the very first thing that you need to know is what are the elements inside these hydrocarbons. Okay, if you are in Form 4, maybe you don't know what is hydrocarbons. Okay, because you are going to learn hydrocarbons in Form 5. But if you're in Form 4, okay, then you need to remember that, or you need to know that for hydrocarbon, it contains carbon and hydrogens. Inside hydrocarbon, there are carbon and hydrogens, these two elements. So if you want to list down all the elements, you must include carbon and hydrogens. And usually for hydrocarbon, they will only give you the percentage of carbons, but they don't give you the percentage of hydrogens. Okay, then you need to find the percentage of hydrogens by yourself. Okay, like in this case, okay, is given that the percentage of carbon is 85.7%, 5.7%. Okay, so what's the percentage of hydrogens? Minus, yes. Okay, yes. So we take 100% minus this 85.7% because 85.7% carbon, and then the remains will be hydrogens, right? Yeah, the whole thing has 100%. So carbon 85.7%, then the remain will be hydrogens. So what is the percentage of the hydrogens? 14.3. Yes, that's correct. Okay, and let's assume that the sample has 100 grams. So what's the mass of carbons? What's the mass of carbons? 85.7. Okay, and hydrogen is 14.3. Okay, now the relative atomic mass of carbon is 12 and the relative atomic mass of hydrogen is 1. Okay, so tell me the number of mole of carbon and hydrogens. Okay, so the number of mole is 7.142 for carbons and 14.3 for hydrogens. Okay, now how about the simple ratio? Okay, so the simple ratio is 1 to 2, right? Okay, so therefore the empirical formula, CH2, yes, that's correct. Okay, one thing that you need to know, in exam they won't give you this table, so you need to know what are the steps for the calculations. First, find the percentage, and then find the mass, find the number of mole, and find the simple ratio. Percentage usually is given, okay, but sometimes they don't give you percentage, they will straight away give you mass. So the step is find mass, find number of mole, find the simple ratio. This example looks easy is because the tables are given, right? Yeah, the table is given for each question, so you found that is easy, okay? But in exam, they won't give you this table, okay? So we have example 5, okay? Example 5. Straight away, tell me what's the empirical formula, okay? Okay, so the answer is P2O3. Okay, so this is the answer. The ratio is 1 to 1.5, but this is not a round number. So what we do is we multiply by 2, okay, both sides to make this 1.5 become round number. because you can't have PO 1.5, right? Because this number must be round number. First, we divide by 0.14 to get the ratio, okay? But after we divide by 0.14, but we still can't get a round number, then we multiply. Usually it's either multiply by 2 or multiply by 3, yeah? Something like that, then you can get a round number. Okay, so then you get this answer, P2O3, yeah?